Hello guys, Mr. Middleton here. Today we're looking at algebraic expressions and equations. At the end of this video, you should be able to define a variable or variables in the context of a problem, and you should be able to write an algebraic expression or equation from words or phrase. A variable is an unknown or changing quantity. Unknown, or let's say hidden. And no, hidden and changing are the same, but I'll change it anyway. A letter is typically used to represent a variable. Okay, you could use symbols if you'd like to. Cursive. Okay, you can use symbols if you like to, or pictures even, but like X, Y, Z are the typical ones that we use. We already talked about expressions, but an algebraic expression is a mathematical phrase that includes at least one variable and does not include an equal sign, contain an equal sign. Okay, we looked at that at the end of last, or one of the previous notes when we were like 5x plus 2y, evaluate that when x is 5 or something. Okay, an algebraic equation is a mathematical, instead of saying phrase here, we're going to say sentence. Okay, so these words kind of start off the same, with the E, expression and equation, but an expression does not have an equal sign. An equation has an equal sign. That includes at least one variable and does contain an equal sign. Equal sign is like the word is, which can change a phrase into a sentence. Okay, a number increased by 4. Algebraically, we'd be like, well, I don't know what a number is. I'm going to use in for number. Increased by 4 plus 4. That is the example of an algebraic phrase. A number increased by 4 is 7. Well, now we'd say, okay, a number increased by 4 equals 7. Expression, equation. Expression, no equal sign. Equation equals. So from there, moving, now that we know the difference between equation and expression, let's talk about defining a variable. Now, when I say define variable, that does not mean like, oh, it's an unknown number, or I don't want that every time. Defining a variable means knowing what it stands for in your equation. Okay, so when we define a variable, we are stating what our letter represents or stands for in a specific situation. Without doing so, we risk our variable having no meaning. Okay, and that will bite us later if that happens to us, especially as we're solving problems where we're trying to find meaning. So define a variable and write an algebraic expression for the following phrase: Mark's weight minus 12. Okay, so a lot of people would be like x minus 12. That works out. I am not married to the letter X, so I like to use a bunch of different letters. M minus 12, because later on I'm like, well, why did I use M? Oh yeah, M stood for Mark's weight. Okay, that's what it meant. So later when I answer this question, I say, well, does that answer make sense? I'm talking about Mark. If my answer is 2 pounds, or if my answer M equals 2, I'd be like, wow, Mark weighed 2 pounds? I've never even heard of a baby being born 2 pounds. Okay, I would say, well, that doesn't make sense. So having meaning to what M means would help me to make sure that I am not giving a bad answer or an answer that's nonsensical. Okay, let's define a variable and write an algebraic expression for each phrase. The quotient of triple a number and 7. So the variable, the thing we don't know, a number. Quotient should mean division of triple a number and 7. So here's what I'm going to do. Quotient, I'm dividing triple a number, use in for a number, and 7. Number 2, 2/3 of an amount increased by 5. Okay, so 2/3 of an amount, I don't know what amount is, but I'm just going to say A. So 2/3 of an amount increased by 5. 1 less than the number of children. Number of children, C. So if I do 1 less than the number of children, I need to know how many children there are first, and then take away 1 from it. So C minus 1. This is really tricky because a lot of people will say, we'll try to go through the problem and they'll say 1 less than children. Okay, and that's also a problem when you're translating. And so you can kind of think of yourself as being multilingual if you're good at math, because we have to make sure that this is making sense. We can't just say things out of order because we don't talk that way. But we have to make sure that what we're saying is making sense to what we understand. We're talking about 1 less than the number of children. Having the children, taking 1 from it, not 1 minus C. Okay, if I have 5 children, 1 less than the number of children would be 4. But if I did 1 minus 5, that would be negative 4. Okay, I'm trying to give real importance because that's one of those things that creeps up and bites us throughout the year if we're just trying to get through it and we're not thinking past just writing something down. All right, so here we go. It says define variables and write an algebraic equation. Here we go. So very important for us to know the difference here between what's being asked of us here. It's equation. Last time was expression. Remember that an expression does not have an equal sign, where equation will. So here we go. The number of gallons of water used is 30 times the number of trees. So the number of gallons of water, call that G. Number of trees, call that T. The number of gallons of water used is 30 times the number of trees. So gallons of water used is 30 times the number of trees. I wrote an algebraic equation for the sentence. Number 2, the number of goats, nice, is 10 less than triple the number of rabbits. So the number of goats is 10 less than triple the number of rabbits. Okay, again, it's that subtraction thing. I need to know then how many rabbits I have and subtract 10 from it. Actually, it's triple the number of rabbits. So that's 3 times the number of rabbits minus 10. And then from the table, it says total cost change from 10. Okay, it's a little bit harder because it's not like giving us a sentence, or at least it's different. Let me not say harder. It's different because it's not giving us a whole sentence the same way. So I already know that we're going to spend $10. Let's change from a 10, and our change is T. So when we take our $10 bill and we subtract from it the total cost, we get our change. $10 bill minus 10 gives us C. 10 minus 9 gives us C of 1. 10 minus 7.5 gives us C of 2.5. Okay, and so our change, we use the C. Okay, again, so this is so that when I look back at it, I can say, does this make sense? Okay, it's something that's overlooked a lot of times, and especially for people who just use X and Y all the time. They're like, X is this, Y is this, X is this, Y is this, X is this, Y is this. You'll notice that we went through this whole page without necessarily having to use X or Y, okay, even though those are the most common used. But we didn't do that because we wanted to make sure that we had meaning and we could check for the sense of an answer. Okay? All right, see you.